Hello and welcome to this webinar hosted by Element 14. Today we're going to talk about the RIoTboard, Revolutionizing the Internet of Things. With us presenting this interesting topic is Abhishek Rao, Technical Marketing Manager for Element 14 in Bangalore. If you have any questions for Abhishek, please put them either into the chat or the Q&A window, and I'll ask them of Abhishek at the end. Without further ado, I hand you over to Abhishek Rao. Take it away.
Hello all, a very warm good morning to everyone. Welcome to the session titled RIoTboard, that is Revolutionizing the Internet of Things. My name is Abhishek Rao. I'm working in Element 14 as Technical Marketing Manager in Bangalore. The focus of this presentation is to give a brief overview of Internet of Things technology, which is the new emerging cutting-edge technology today available. RIoTboard is a new SPC which supports Internet of Things and is a very popular Android and Linux development tools which can be used for various industrial and commercial applications. So let me just quickly run you through the agenda. So first we will start with defining the Internet of Things technology, and we will have a brief overview about what exactly Internet of Things is. After that we will follow it up with Internet of Things architecture, and a very important point, that is the hardware requirement for Internet of Things technology. Then we will talk about the RIoTboard, which is an open source platform that is available from Element 14 today. We will have a functional view about the RIoTboard. Then we will have a top and bottom view of about how board looks, and you can have a feel about the board. Then we will discuss the features in detail. We will discuss the software features as well and the accessories required for you to kickstart with this board. And finally, we will have a discussion about the applications that this board can support. Now, what is Internet of Things? Internet of Things is an integrated part of future Internet, including existing and evolving Internet and network developments, and could be conceptually defined as a dynamic global network infrastructure with self-configuring capabilities based on standard and interoperable communication protocols where physical and virtual things have identities, physical attributes, and virtual personalities, which uses intelligent interfaces and are seamlessly integrated into the information network. In simple words, the Internet of Things could allow people and things to be connected anytime, any place, anything with anyone, ideally using any path or any network or any kind of service. The Internet of Things is a scenario in which objects, animals, or people are provided with unique identifiers and the ability to automatically transfer data over a network without requiring human-to-human or human-to-computer interaction. And this is a very important point here. IoT has evolved from convergence of wireless technologies, MEMS systems, that is micro-electromechanical systems, and obviously the Internet. Now, what is IoT? Imagine a world where billions of objects can sense, communicate, and share information, all interconnected over a public or private Internet protocol networks. These interconnected objects have data regularly connected, analyzed, and used to initiate action, providing a wealth of intelligence for planning, management, and decision-making purposes. This is the world of Internet of Things. The IoT concept was coined by a member of Radio Frequency Identification Development Community, that is RFID community, in 1999, and has recently become more relevant to the practical world, largely because of the growth of mobile devices, embedded systems, various different types of communications available today, cloud computing, and also data analytics. Since then, many visionaries have seized the phrase Internet of Things to refer to the general idea of things, especially everyday objects that are readable, recognizable, locatable, addressable, and or controllable via Internet, irrespective of the communication means. It can be via a RFID network, or it can be via a wireless LAN or wide area networks, or any other means that is available today, or that can be available in the coming future. Everyday objects include not only the electronic devices we encounter, or the products of higher technological development such as vehicles and equipments, but things that we do not ordinarily think as electronics at all. such as food and clothing. Example of things include people, location of the objects, time information of the objects, and condition of the objects. These things of the real world shall seamlessly integrate into the virtual world, enabling anytime, anywhere connectivity. Now let us have a look at number of connected devices by 2020. Now, in 2010, the number of everyday physical objects and devices connected to the internet was around 12.5 billion. Cisco forecast this figure is expected to double to 25 billion in 2015, and the number of more smart devices per person increases to a future of further 50 billion by 2020. With more physical objects and smart devices connected in the IoT landscape, the impact and value of that IoT brings to our daily lives becomes more prevalent. People make better decisions such as taking the best route to the work or choosing their favorite restaurant. New services can emerge to address society challenges such as remote health monitoring systems for elderly patients, and it can also be pay-as-you-use services that is available today. For government also, IoT can be used in a way like the convergence of data sources on shared networks, improves nationwide planning, promotes better coordination between agencies and facilities, and facilitates quicker responsiveness to emergencies and disasters. For enterprises, IoT brings about tangible business benefits from improved management and tracking of assets and products. New business models and cost savings can be achieved through the optimization of the equipment and resource usage. Now let us have a look at the IoT architecture. IoT architecture consists of different suite of technologies supporting IoT. It serves to illustrate how various technologies relate to each other and communicate the scalability, modularity, and configuration of IoT deployments in different scenarios. Now let us have a look at the IoT architecture modules. At the bottom we can see sensors and connectivity network, which is the most important part of this IoT architecture. Then we can see the gateway and networks, where a lot of different types of communication protocols and technologies are involved in this IoT architectures. Then we can have a look at the management services block, which is quite an important block, to create the protocols and rules about this complete IoT architecture. Then finally, and probably the most important thing, is the applications layer, where we can use and control different types of applications that we use in our day-to-day lives. Now, let me just talk about the sensors layer. This lowest layer is made up of smart objects integrated with sensors. Sensors enable the interconnection of physical and digital worlds, allowing real-time information to be collected and processed. The miniaturization of hardware has enabled powerful sensors to be produced in much smaller forms, which are integrated into objects in this physical world. There are various types of sensors available for different purposes. Sensors have the capacity to take measurements such as it may be temperature, or we can measure the air quality of our environment, or we can use it for motion sensing or sensing electricity also. In some cases, they may also have a degree of memory, enabling them to record a certain number of measurements, and which will be the most evolving technology in the sensors today. A sensor can measure the physical property and convert it into the signal that can be understood by an equipment or the instrument. Sensors are grouped according to their unique purposes, such as environmental sensors or body sensors, home appliance sensors, vehicle sensors, telematic sensors, etc. Now, let us look at the second block, that is the gateway and networks block. Most sensors require connectivity to the sensor aggregators, and these aggregators are called as gateways. This can be in the form of local area network, that is LAN, such as Ethernet and Wi-Fi connections, or personal area network, that is PAN, such as Zigbee, Bluetooth, or ultra-wideband networks. For sensors that do not require connectivity to the sensor aggregators, Their connectivity to the backend servers or applications can be provided using wide area networks, that is WAN, such as GSM, GPRS or LTE. These are the technologies that are available today. Sensors that use low power and low data rate connectivity, they typically form networks commonly known as wireless sensor networks, WSNs. WSNs are gaining popularity as they can accommodate more sensor nodes while retaining adequate battery life and coverage in large areas. On top of the gateway networks module, we can see the management service layer. The management service renders the processing of information possible through analytics, security controls, process modeling, and management of devices. One of the important features of the management service layer in the business and process is rule engines. IoT brings connections and interactions of the objects and systems together, providing information in the form of events or contextual data such as temperature of goods, current location, and traffic data. Some of these events require filtering or routing to post-processing systems, such as capturing of periodic sensory data, which is very important in the real-time applications, while others require response to the immediate situations, such as reacting to emergencies. It can be on patient's health conditions. The rule engine supports the formulation of decision logics and trigger interactive and automated processes to enable more responsive IoT systems. Now let us have a look at probably the most important layer in the IoT architecture, that is the application layer. There are various applications from industry sectors that can leverage on IoT. Applications can be verticalized, ones that are specific to a particular industry sector, and others such as fleet management, asset tracking, surveillance that can cut across multiple industry sectors. IoT has applications such as crowd control during emergencies and events, intelligent lampposts to save energy. In retail industry, IoTs can be used for shopping assistant applications that can be used to locate appropriate items for the shoppers and provide recommendations of the products based on the consumer preferences. In healthcare, IoT can be used for elderly family member monitoring, continuous patient monitoring, and smart pills, which is quite an emerging technology today. In transportation, IoT can be used for accident avoidance detection. It can be used for distributed urban traffic control systems. And this is very much important in managing energy, that is energy management systems in the future. Now, hardware requirements for IoT. There are three important things that I can understand today about the hardware requirements of IoT. That is, it should be developer friendly. That is, it should help us to program like we are used to without letting us to waste time with complex or new environments. It should support standard programming languages and tools that is available today or that can be optimized in the coming future. And it should have minimized hardware-dependent code, or it should have zero learning curve for embedded programming and multi-platform support like Linux and Androids. Second point that we can see is resource-friendly. It should be resource-friendly. It should be robust and must have code footprint flexibility, which is very important in any of the IoT systems, enabling maximum energy efficiency and which will give us the real-time capability. So IoT hardware should be real-time. And third thing is it should be IoT friendly. That is, it should make your applications ready for even smaller things in the internet, which should have the common system support for all kinds of applications. Now, let us come to our main course, that is RIoTboard. RIoTboard is an open source development platform, which is a low-cost, fully featured single board computer developed to address the needs of demanding applications requiring high levels of processing power on an open source platform. RIoTboard is first and foremost an open source board with detailed schematics available for download. which will be useful in your design. Additionally, RIoTboard community also provides Android OS distribution for applications requiring tablet and mobile experiences, etc., or multimedia experiences. Distribution of Linux can also be downloaded from the RIoTboard community, giving you the complete flexibility of the open source platform that is available today. RIoTboard has been designed for and supported by a community of design engineers and application developers. So a lot of support is available on the board. The hardware design has an optimized form factor, and I guess this is very important, which utilizes one of the latest high-performance multimedia processors and which has been optimized for low power consumption. I mean, whenever you are designing, addressing these key design challenges upfront will reduce your development time of your end product and time to market of the product. RIoTboard has been designed to run both Android and Linux operating systems very efficiently and features a high processing performance, low power consumption processor with a broad range of peripherals and display capabilities, making it perfectly suited as a hub for Internet of Things. Now let us have a look at the functional block of the RIoTboard. As we can see, it has plenty of interfaces available. This RIoTboard is an evaluation platform featuring the most powerful IMX6 Solo, a multimedia application processor with ARM Cortex-A9 core at 1 GHz from Freescale Semiconductor. This platform helps us to evaluate the rich set of peripherals, as we can see it here in the functional block diagram, which includes a gigabit Ethernet port, which has a HDMI 1.4 version interface, which has a LVDS interface, which has analog and microphone interfaces, which has micro SD and SD card interfaces, which has a couple of serial and USB interfaces available. It also has a JTAG interface, which is very commonly used for debugging. It has multiple camera interfaces. It has GPIO boot configuration interfaces, to select your boot modes. It has an expansion board giving us a lot of functionalities for connecting additional peripherals onto the board, as we can see it here on the functional block diagram. Now, this is the top view of the RIoTboard. We can see plenty of interfaces that we discussed in our functional block diagram view, and each of these interfaces we will discuss in detail in the coming slides. This is the top view of the board. This is the bottom view of the board. We can see a couple of interfaces here as well. And as we can see, it is a multi-layered PCB. Now, let us discuss about the RIoTboard features. Mechanical parameters. RIoTboard has a working temperature of 0 to 50 degrees centigrade. It has a humidity range of 20% to 90%. It has a dimensions of 120 mm by 75 mm, and you can see it is quite compact with the features and the interfaces that is loaded onto this board. The power requirements is 5 volt, and the current requirement would be 1 to 4 amps for this particular board based on the peripherals that you are going to add onto the board. Now let us have a look at the most important part in this board, that is the processor. As we can see, IMX6 series unleashes the industry's first truly scalable multi-core platform that includes a single, dual, and quad-core families based on ARM Cortex-A9 architecture. Together with a robust ecosystem, the IMX6 series provides the ideal platform to develop a portfolio of end devices based on the single hardware design. IMX6 family offers some of the most versatile platforms for multimedia and display applications, bringing personality and interactivity together to a whole new world of products. It has a high-performing video processing unit which covers SD-level and HD-level video decoders, SD-level encoders, and a multi-standard video codec engine. It has an OpenGL ES2.0 3D graphics accelerator with a shader, and that is why it can run Android very efficiently. and also a 2D graphics accelerator for superior 3D and 2D and for superior user interface acceleration. With high-performance multimedia processing and integrated power management systems, the IMX6 series is the purpose-built for the new era of smart devices. So, briefly speaking, IMX6 Solo is based on ARM Cortex-A9 processor which operates at 1 GHz. It has a 32 KB L1 instruction buffer. It has a 32 KB L1 data buffer. So we can see it here. It has two different buffers for instruction and data. It has a private counter and it has a watchdog timer. So it has a Cortex-A9 Neon MPE, that is Media Processing Engine coprocessor built on it. Onboard memories. It has a 4 GB eMMC memory on board. This is an embedded non-volatile memory system which comprises of both flash memory and flash memory controller integrated on the same die. And Android operating system will come loaded into this memory as a default with this board. It has a 1 GB of 16-bit wide DDR3 RAM operating at 800 MHz. So we can see we have a very good RAM available on this board, which can be used for most of the applications, which will suffice most of the applications today. Media interfaces available. It has an analog headphone microphone of 3.5 mm audio jack. It has an LVDS interface, which is a display interface that is commonly used today. It has a HDMI interface, HDMI 1.4 version. It has an RGB parallel interface for display that is available on the expansion port, which we will discuss in detail in the coming slides. It has two camera interfaces, and this is where it gets quite exciting. It can support CCD cameras or it can support CMOS cameras as well. It has MIPI lanes at 1 Gbps, so you can see it has its connectivity to the MIPI lanes is high speed. Now let us have a look at the data transfer interfaces. It has 3-pin TTL interface which can be used for debugging. It has a couple of serial ports. It has a 3-line serial port which supports TTL logic. It has plenty of USB ports. It has one USB 2.0 OTG which is on a USB mini connector on the board. It has 4 USB hosts, that is Type A connectors, high speed. It has micro SD card interface. It also has a SD card interface, and it has a gigabit Ethernet interface on board. It also has a 2-channel I2C interface that is available on the expansion port. It has a 2-channel SPI interface that is also available on the expansion port. It has 3-channel PWM interface. That means it gives 3 hardware PWMs output on the expansion port. It has plenty of GPIO pins available on the expansion port. It has a 10-pin JTAG interface which can be used for debugging. And it also supports Freescale's technology, OpenSDA technology, that is serial debug adapter interface on a mini USB on the board. Now, other features that we can look out on the board is it has a power LED, so whenever you connect the power, you can see the board operating. It has a one OpenSDA LED, so whenever you are using the OpenSDA interface, you can figure it out by looking at the LED available for this. It has 2 user-defined LEDs. These are LEDs that can be used by users for any of the applications which are mounted on board. It has a 1 DC jack. This is a DC power jack for connecting the power to the board. It has a reset button on the board, which is quite important feature added onto this board now. It has a boot configuration interface, to select the boot modes on the board. Now, we are looking at the power input jack that is available on the board, and that is highlighted here in the image that you are able to see. It requires a 5-volt 1 ampere plus AC to DC power supply to be plugged into this power jack on the board. It is not recommended to use a higher voltage since possible damage to the board may result due to failure of the protection circuitry. It has a LVDS interface. LVDS is low voltage differential signaling, and as we know, LVDS operates at a low power and can run at very high speeds using normal cables. Hence, we can connect any kind of LVDS displays on the board. We can connect one port up to 165 megapixels per second or two ports up to 85 megapixels per second. For example, WUXGA at 60 Hz each. It has a HDMI 1.4 interface for connecting different types of HDMI displays that is commonly available today. We can connect any kind of LED TV that has an HDMI interface. We can connect any types of LED TVs that nowadays comes with the HDMI interfaces, making your connectivity, display connectivity onto this board very easy. Now, RIoTboard provides a 3.5 mm stereo connector for microphone input, as we can see it in the image. Now, it also has an audio output jack. A headphone or any speaker with a standard 3.5 mm stereo jack can be connected to this audio output to get the audios from the board. It has a SD card interface, and this SD card can be expanded up to 64 GB. It also has a micro SD or MMC card interface, which also to this interface also we can connect the memory cards up to 64 GB. As we can see here, we have plenty of data storage options available on the board. Now, CSI interface, that is camera serial interface, defines the interface between peripheral device, that is a camera, and a host processor. This MIPI CSI2 serial camera port supports up to 80 Mbps to 1 Gbps speeds per data link. Hence, we can connect any camera which has CSI interface easily. It also has a camera interface to connect CMOS cameras onto the board. Hence, RIoTboard, as we can see it here, has two different options to connect multiple cameras with different interfacing technologies. It has a 10-pin JTAG interface integrated into this development board for debugging and testing purposes, as we can see it here on the image. It has a mini USB interface. The mini USB is connected to the high-speed USB 2.0 OTG module, that is on-the-go module of IMX6 application processor, which can act as host as well as the device for data transfer and communications. It has a three-pin serial interface, that is, it provides TX, RX, and grounds, and can be used for logging through the terminal ignition programs. And you can create a session onto the board. Now, it has a 40-pin expansion port. This 40-pin connector is having 11 GPIO connectors, that is general purpose input IO pins, that can be configured to connect any of your inputs or outputs in the outside world. It has 3 UART. There's 3 hardware PWMs. It has 2 I2C. It has 2 SPA interfaces, as we can see, making it very powerful to connect a lot of other peripherals or a lot of other devices to the board. It has an OpenUA SPA interface on a mini USB connector, as we can see it here on the image. Now this OpenSTA is a low-cost debug and programming interface embedded in most of the Freescale boards. It handles debug communication between PC and target via USB technology. Now it has an RGMI LAN interface. Now RIoTboard has this reduced gigabit media independent interface. This Ethernet connector contains integrated magnetics, which allows the Ethernet IC to auto-configure the port for correct connection to either to a switch or directly to a host PC on a peer-to-peer network. It is not necessary to use any kind of crossover cables when you are connecting directly to another computer. USB hub interface. It has 4 USB 2.0 hosts supporting speeds up to 480 Mbps. We can see we have plenty of USB ports available to connect any kind of plug-in modules that supports USB onto the board apart from your keyboard and mouse. So you don't need any kind of additional USB hubs to connect your other peripherals to the board. Now let us have a look at the software features. Operating systems. It supports Linux. It supports Ubuntu 11.10 version and it has Ubuntu development tools available as well. It supports Android 4.3, that is Jelly Bean, which comes loaded in the SD card, which comes loaded in the eMMC card actually, and it also has a very powerful Android development tools available to build any of your applications on top of Android. A very important part is having drivers, that is device drivers, for all the interfaces and peripherals on the board. So as we can see it here, it has a serial series driver. It has a RTC hardware clock driver available. It has a Ethernet port driver. It has display drivers for LVDS and HDMI. It has MMC and SD drivers. It has USB drivers available. It also has audio drivers. It has drivers for camera and LED. All these drivers and this operating system can be downloaded from the Element 14 community website. Advanced Power Management Unit. Now the IMX6 Solo processor integrates advanced power management unit and controllers. Now, as we can see it here, it includes LDO supplies for on-chip resources. It uses temperature sensors for monitoring the die temperature. It supports TVSS technique for low power modes. It uses SW state retention and power gating for ARM and MEP cores. It supports various levels of system power modes. It uses flexible clock gating control scheme, making a very good power management unit in this processor. Hardware accelerators. IMX6 Solo processor uses dedicated hardware accelerators to meet the targeted multimedia performances. The use of hardware accelerators is a key factor in obtaining high performance at low power consumption numbers while having CPU core relatively free for performing other tasks. The IMX Solo processor incorporates these hardware accelerators as we can see it here. It has a video processing unit, that is VPU. It has an image processing unit version 3H. It has 3D graphics processing unit, which is quite powerful, that supports OpenGL ES 2.0 version 5. It also has a 2D graphics processing unit version 2. It has ASRC, that is asynchronous sample rate converter. As we can see, it has quite powerful hardware accelerators available for this board. A very important part today comes when you are connecting anything to the internet is security. So it has plenty of security functions available. Security functions are enabled and accelerated by these of the following hardwares. It has an ARM Trust Zone including the TZ architecture, which helps us to separate interrupts and memory mapping, etc. There is SJC, that is System Data Controller, which protects data from debug board attacks by regulating or blocking the access of system debug features. There is CAM, which is very important today, that is Cryptographic Acceleration and Assurance Module, containing cryptographic hash engines, 16-bit secure RAM, and true and pseudo-random number generators, and these all are certified by NIST. It has SNVS, that is Secure Non-Volatile Storage, which also includes Secure Real-Time Clock. It has CSU, that is Central Security Unit, which enhances for IC Identification Module, that is IIM, and will be configured during boot by EUFUSEs and will determine the security level operation modes as well as the TZ, that is Trust Zone Policy. It has AHAB, that is Advanced High Assurance Boot, version 4, with the new embedded enhancements such as SAH256. It can be 2048-bit RSA key, version control mechanisms. It has warm boot. It has CSU and TZ initializations. Now, what are the accessories required for you to kickstart with the RIoTboard? First of all, you require a power adapter. It must be a 5-volt 1 amp plus power adapter for powering up your board. You would require an Ethernet cable or a Wi-Fi adapter to connect your board to the internet. You will require a HDMI cable if you are going to use HDMI port as your display for your display function. You will require a LVDS display. Now, this LVDS display is available with Element 14. And LVDS is a technology which is quite largely used nowadays today for display. You may require a 4 GB SD card or micro SD card memory card if you are going to use Linux as well. You can use this as a multi-bootable, multi-platform board. You can boot with Android, which is by default available on the board in the eMMC 4 GB eMMC card, or you can boot it through any of this SD or micro SD interfaces by installing the operating systems on a 4 GB SD card. You may require a detailed USB debug cable, which is very important for your debugging of the board, hardware debugging. Now let us have a look at the applications. The RIoTboard can be used for netbooks, that is web tablets. It can be used as net tops. Those are internet desktop devices that is very commonly used today. It can be used in high-end mobile interface in mobile internet devices, that is MIDs. It can be used in high-end PDAs. It can be used in high-end portable media players, that is PMP, which has HD video playback capabilities. It can be used as portable navigation devices, PNDs, which is gaining a lot of popularity nowadays. It can be used in industrial control and test and measurements. It can be used as SBCs, that is SBC single board computers. You can use Android or Linux on this. And the exciting feature is you can create a lot of Android apps. As this board has Android development tools available, you can create any kind of apps or any kind of applications or requirements as per your wish and upload that apps onto the cloud. Now, if you want any kind of support from Element 14, you can contact us through any of our support channels. That is, you can contact us through email, live chat, or phone, or you can visit our forums to see the discussion, to see the technical discussion that happens on this board. You can visit our learning centers and download the materials online from our community. A lot of videos are available about this board on our community, which can be viewed and downloaded. You can do a lot of polls. Polling options are available for this board so that you can rate this board as per your usage and requirement. And a lot of materials about this board, operating system softwares are available for download on the Element 14 community website and more. You can see this web link available displayed on the slide here. You can go to this web link and get any kind of data or support that is required for you on this board. If you have any questions, you can mail me at arao@element14.com, or you can ask me right away. And if you want to buy RIoTboard and accessories, you can get in touch with us at in-sales@element14.com. Thanks.
Thank you very much, Abhishek. If anybody in the audience has any questions, please put them either into the chat or the Q&A window now. Abhishek, I've got a question. Is that you've mentioned a number of things that the RIoTboard can do, and you've also talked very extensively about the Internet of Things and what kind of applications that you can get out of that. I'm wondering if you can bring it together a little bit. Is that what kind of applications do you see the Internet of Things applications do you see the RIoTboard being used in? For example, you mentioned smart streetlights as an Internet of Things application. What kind of smart applications do you see the RIoTboard being used for?
Okay, as you're talking about the smart street lights, let us say street is completely vacant in night. The lights will be continuously on. So, I mean, in such cases, it is not energy efficient. In a country like India, where power is always a crisis. So, in such cases, if we can have some kind of sensors, occupancy sensors, wherein if somebody comes to that street, that particular street light will glow, and when nobody is there, that street light will go off. And this control can be done using the IoT technology hardwares, where we can have a centralized system, centralized server, where we can have a couple of them monitoring this kind of systems and control the overall lighting architecture of this city, making it very energy efficient, and same energy can be used for some other purposes. Or I can take an example of healthcare. Let us say, I mean, there is some kind of accident that has happened to a person who is going in a car. So a car will be connected in this Internet of Things architecture. So car will communicate to the nearby hospital. It will call the ambulance very quickly, which will remove the human-to-human or human-to-machine interfaces. So in such cases, I mean, today practically what happens is if there is an accident, somebody has to make a call to the hospital. And in this case, we lose a lot of precious time, a lot of life-saving time. And in such cases, the time is very critical. So whenever there is an accident, if your car can call the ambulance and inform the hospital about the state you are. I mean, if you are having some body sensors, it can obviously tell about the damage that has been caused to your body, so that hospitals can make preparations before you enter the hospital, and which is a very vital time for when it comes to life saving. So does that suffice your question? Yeah.
Yeah. Next question is essentially, what makes the RIoTboard particularly good as an IoT development platform?
Okay. For IoT, as I've told, it should be an open source platform. If you have some licensed platform, or if you have a closed platform, I mean, many of the times when you're doing a lot of developments, you will face a lot of restrictions or licensing issues. So open source platform gives you the complete flexibility to adapt this board as per your design, and which is a very important thing, as I've discussed in one of my slides. That is a basic requirement for IoT, which should have an open source platform and which can work on most of the common architectures or almost all the common platforms. So I guess this is a very important feature of this board, which which will help you to support for the IoT technology.
Okay, thank you for that. Do we have any further questions from the audience? Going once, going twice. Okay, I'd like to thank you, Abhishek, for this fascinating presentation on both the Internet of Things and the RIoTboard. Stay tuned to Element 14 for future webinars on the latest technologies and the products that will support it. Until then, I'd like to thank you again, Abhishek, and thank you to our audience, and say goodbye. Goodbye, everyone.
Goodbye.